In this video, I want to review how to evaluate trig functions at quadrantal angles. For those in pre-calc, that's in section 4.4 of your text. Let me just remind you what a quadrantal angle is. In degrees, it would be any multiple of 90 degrees. And remember, when I say multiple, that includes positive multiples of 90, like 90 and 180 and 270, but that also includes 0 copies of 90 degrees, which would be 0 degrees, and negative multiples, so negative 90 degrees, negative 180 degrees, etc. Okay. Of course, 90 degrees in radians is pi over 2. So in radians, a quadrantal angle is just any multiple of pi over 2. And the significance of a quadrantal angle is that if I draw it in standard position, so that the initial ray is on the positive x-axis, then every time I go pi over 2 in any direction, I'm rotating through an entire quadrant, the terminal ray is going to land on one of the axes. Okay. Which means, if this is my unit circle here, the terminal ray will pass through one of these 4 points. Now, on the unit circle, I know the radius is r. I'm concerned about what are the capital X and capital Y values where the terminal rays of a quadrantal angle would intersect the axes. So let's just label the coordinates of these points. This point, we're on the capital X axis. And again, the fact that I'm using capital letters is just a notational convenience so that if I wanted to call my angle X, I wouldn't confuse it with this capital X here. Okay. If we're on the capital X axis, our Y value is 0. But I know this is the unit circle, so this distance has to be 1, so that point is going to be 1. For this point up here, now we're on the capital Y axis, which means our X value is 0. But again, this distance has to be 1, and I can see we're going up, which is the positive direction, so that's going to be 0, 1. At this point, we're back on the capital X axis, so our Y value is 0 again. I know this distance is 1, but now we're to the left of the origin, so the capital X value would be negative 1. And then down here, we're back on the capital Y axis, so X is 0, and the capital Y value would be negative 1, because this distance is 1, but we've gone down, so it's got to be negative. Okay, so I want to just work through a few of these. Most of my examples here are in radians, because at least by the time you're in calculus, you're almost always working in radians. But I threw in one example in degrees too, just so we remember that we can do that. And in pre-calculus, we will be going back and forth between the two. All right, so sine of 0. Okay. So 0 means don't go anywhere. So the terminal ray is the positive x-axis. Sine is the capital Y value, so that's going to be 0. This output of my trig functions I'm going to refer to as a trig ratio. That one doesn't happen to get written as a fraction, but remember, this came from y over 1, because that was coming from opposite over hypotenuse. So it's just a fraction that's simplified. All right, cosine of 180 degrees. So if I start here and I rotate 180 degrees in the positive direction, that's going to take me to here. So the terminal ray is the negative x-axis. Cosine is the capital X value, so that's going to give me a negative 1. Okay, tangent of pi over 2. So I rotate pi over 2, which is the same as 90 degrees. My terminal ray is the positive x-axis. Now, tangent is supposed to be y over x, and I see a problem. Now, if I see that problem, I can not write what I'm about to write. If I didn't see that problem, I could say, oh, y over x is 1 over 0, and now I see the problem, and I am immediately going to cross that off. Division by 0 is undefined. Don't write it. What I'm going to write is undefined. Okay. And for those of you, particularly in my class, don't write both, because then you've given me one correct answer and one incorrect answer, and I will grade them both. Okay? Don't want you writing that we can divide by 0. It's undefined. Just tell me that. So the circle definitions expanded the domain of our trig function so that we can include almost anything. But tangent, secant, cosecant, and cotangent all had either a capital X or a capital Y in the denominator. they're going to be undefined if that variable is 0. That only occurs at one of these 4 points, so it only occurs for quadrantal angles. Okay, let's try tangent of pi. Pi is a half of a revolution, so that's the same as 180 degrees. Now if I do y over x, that's 0 over -1. I do want to simplify that, but that simplifies to 0. So 0 on top, great. 0 on bottom, undefined. Let's try cotangent of pi. Okay. Now, cotangent of pi would be the reciprocal of tangent, but I like to think of it as just x over y. Take the reciprocal of the formula. Okay. Because, let's see, cotangent of pi in this case, ooh, that would give me -1 over 0. I can't have that. That's going to be undefined. But notice, if I asked for cotangent of pi over 2, I can't think of that as the reciprocal of tangent of pi over 2, because the reciprocal of undefined doesn't make sense. But if I take the reciprocal of this formula and say, let me look at what x over y is for the terminal ray of pi over 2, that would be 0 over 1, and that's just 0. So that's not saying that 0 is the reciprocal of undefined, but it is saying that when tangent is undefined, that will mean that cotangent is 0. Okay, just because it occurs, that occurs at a point where the capital X value is 0, and that makes the denominator of tangent 0, so it's undefined. That makes the numerator of cotangent 0, which makes it 0. Okay, so I've got a few more up on the board here. What I'm going to suggest you do is pause the video, try to work out the answer to these 4 additional problems, and then tune back in and we'll check them together. All right, here are the 4 problems that I left with you. I'm going to just write the answers over to the left of them. Sine of 3 pi over 2. So 3 pi over 2, well, that's pi over 2, 2 pi over 2, 3 pi over 2 puts me down here on the negative y-axis. Remember that sine is the capital Y value, so that's -1. Next one is cosine of negative 3 pi over 2. Do be careful with that negative sign. That means we're going to rotate clockwise. So we start here, negative pi over 2, negative pi, negative 3 pi over 2. We're up here on the positive y-axis. Cosine is the capital X value, so that's going to be 0. Secant of negative pi over 2. So that's going to be the reciprocal of cosine. Negative pi over 2, I'm rotating down to here. Cosine would be the capital X value. That's 0. I can't take that reciprocal, so that one's going to be undefined. Okay. And then cosine of 5 pi over 2. So let's see, here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 would be 2 pi, 5 pi over 2 we've rotated past that, so it's 1 1/4 revolutions. We wanted cosine, that's the capital X value, and so that's going to be 0. You'll notice as we were working with our quadrantal angles, there are only 4 answers that we can get. We can get 0, 1, -1, and undefined. And that's because we're looking at these trig ratios, but the only numbers we have to work with are 0s, 1s or -1s, and then the radius of the unit circle, which is 1.